Miles to go, students. Today we are going to discuss about some important identities and properties of integers. So let's start with the additive identity. The sum of any integer and 0 is the integer itself. 0 is the additive identity for integers. That means if I add any integer to 0, the result is the same integer. For example, if I add 2 to 0 in any order, the result is 2 itself. Multiplicative identity. The product of any integer and 1 is the integer itself. 1 is the multiplicative identity for integers. For example, if we find the product of 5 and 1 in any order, the result is 5 itself. Here is a note for you. Every integer multiplied with 0 gives 0. What does it mean? That means if I multiply any integer with 0, the result will always be 0. Additive inverse. Minus a is the negative or additive inverse of a. That means if a is an integer, then there exists another integer minus a such that when we find the sum of these two integers, the result is 0. In simple words, we can say that the additive inverse of positive integer is negative and additive inverse of negative integer is positive. For example, additive inverse of positive 3 is minus 3 and additive inverse of minus 3 is positive 3 and additive inverse of 0 is the 0 itself. Here are some major properties of integers: closure property, commutative property, associative property and distributive property. So let's start with the closure property. Integers are closed under addition, subtraction and multiplication. That means if we find addition, subtraction and multiplication of two integers, the result will be an integer. But same property is not applied to division, because if I take two integers 1 and 0 and if I divide 1 by 0, the result will be not defined. Commutative law or commutative property. For integers, addition and multiplication are commutative. As we can see here, if I add 7 and 2 in any order, the result is 9. And same with the multiplication. If I multiply 5 and 3 in any order, the result is 15. But same property is not applied to subtraction and division. Why? As we can see here, if I subtract 5 from 6, the result is 1. But if I change the order and subtract 6 from 5, the result is minus 1. That means results are changed. Same with the division. So this property is not applied to subtraction and division. Associative law or associative property. Integers follow the associative property for addition and multiplication. For example, if I take an example of addition, if I have three integers 2, 3 and 5, as we can see here, 2, 3 and 5. Okay, now if I first add 2 and 3, then result is added to 5, the result is 10. But in second case, if I first add 3 and 5, then result is added to 2, then result is again 10. That means result doesn't change. Same with the multiplication. If I take 3 integers and multiply them, if I multiply any two of them first, then result is multiplied to the third integer, the result doesn't change, as you can see here. But same property is not applied to subtraction and division. As we can see here, if I apply the same property in subtraction and division, the results are different. Distributive property. This is the property of multiplication which is performed over addition and subtraction. Suppose I have a expression. Suppose if I have to solve this expression through BODMAS rule, then first I will solve the value which is in the bracket, then result will be multiplied to 5. But if I have to solve the same expression through distributive property, then what I will do, I will first multiply 5 to 3 3 as we can see here, then put the plus sign, then I will again multiply 5 to 2, then I will perform the operation according to BODMAS rule and get the answer. Same procedure is followed over subtraction. As we can see here, what I will do, first I will multiply 5 to 3 and then put the minus sign, then I will again multiply 5 to 2, then perform the operation according to BODMAS rule and get the answer. I hope you have understood all the properties very well. See you in next video. Till then, stay safe, stay happy, miles to go.